Chemistry. Chemistry does not change one type of atom into another. Chemistry does not change the nucleus of an atom. Chemistry is all about how the electrons of atoms interact with the electrons of other atoms. There are rules of chemistry which determine which reactions are possible, which reactions require energy, and which reactions release energy. Let's start with a basic rule and apply it to our first two elements, hydrogen and helium. An atom that is alone with a single electron is not stable. To be stable, an atom needs a certain number of electrons. The first stable number of electrons is 2. 2 electrons together are stable. 1 is not. Keep in mind that this rule applies to electrons only, not protons or neutrons. As a result of having 2 electrons, helium has nothing to gain from other atoms. Helium does not get involved in chemical reactions. Helium is inert. Hydrogen is not chemically stable since its single electron is alone. What is the simplest solution to this problem while keeping the hydrogen electrically neutral? Equal numbers of electrons and protons. Remember, you can't change anything in the nucleus. Discuss. If 2 hydrogen atoms join together, each will have a share of 2 electrons. Each hydrogen atom's electron will have a partner. This hydrogen molecule is still electrically neutral since it has 2 protons and 2 electrons. It is still 2 separate atoms with 2 separate nuclei, but its electrons are shared. This sharing of electrons to make 2 atoms chemically stable is a type of chemical bond. There are 3 major types of bonds: covalent, ionic, and metallic. This type of chemical bond with shared electrons is called a covalent bond. Atoms held together by covalent bonds are molecules. A covalent bond enables 2 atoms to share electrons, bringing each to a number that is stable, the number in an inert atom. In this case, each hydrogen atom has a share of the same number of electrons as neutral helium, 2. We will first learn about covalent bonds in molecules. Hydrogen atoms are almost never found alone. They are either bonded with another hydrogen atom to form a hydrogen molecule, or are bonded to some other element. The name for a hydrogen molecule is H2. The subscript 2 indicates the number of that type of atom in the molecule. H2 has 2 hydrogen atoms. The number of covalent bonds an atom can make depends on how many electrons it's looking to borrow and share from other atoms. Hydrogen is looking for 1 more electron, so hydrogen can make exactly 1 bond. 2 hydrogen atoms forming a chemical bond to form a hydrogen molecule is our first chemical reaction. It is written this way, or better yet, this way. Chemical equations have coefficients and subscripts. Coefficients indicate the number of particles. Subscripts indicate the number of a type of atom in the particle. Normally, we don't show those if they're 1, but we have added them below for clarity. So the coefficients here are 2 and 1, and the subscripts are 1 and 2. A chemical reaction cannot change the number of each type of atom, just how they're combined to form particles. In this case, there are 2 hydrogen atoms on each side of the equation. On the left side, there are 2 particles with 1 hydrogen atom in each. On the right side, there's 1 particle, but each particle has 2 hydrogen atoms. The particles and the number of particles are different, but the number of hydrogen atoms is the same. A chemical reaction cannot create or destroy atoms, nor can it change one type of atom into another. A chemical reaction just changes how atoms are combined, changing one set of particles into another. So the number of each type of atom has to be the same before and after a chemical reaction. This is conservation of matter. The mass of each atom is also unaffected by a chemical reaction. Since the mass and number of each type of atom is unchanged, the total mass of the atoms before and after a reaction is the same. If we start with 4.2 grams of substances, we end with 4.2 grams of substances. This is conservation of mass. A covalent bond between two atoms is drawn as a line, such as in the hydrogen molecule model below. The line represents the covalent bond between the two atoms. 2 electrons comprise each bond, 1 from each atom. On the following slides, a number of other ways to depict a molecule are shown. This is a ball and stick drawing of hydrogen molecule. The balls represent the hydrogen atoms and the stick represents the chemical bond. This image shows where the 2 electrons are most likely to be found in H2. While this is a schematic drawing showing the chemical bond as the 2 shared electrons.